This video is going to cover the AP Unit 3.7, which is sinusoidal function, context, and data modeling. So we're going to do a lot of word problems in this section. You're also going to want your graphing calculator because we're going to do the regression on the calculator for a couple of things. So we start with obviously some review of what we've been talking about in the last couple of sections, which is our sinusoidal functions. We are going to use either sine or cosine for these functions. Remember, the A on the front is the absolute value of, or the amplitude is the absolute value of A. If A is positive, then my sine curve starts at 0, goes up, down, down, up. And if it's negative, it's flipped. If my A is positive for cosine, then we start at the amplitude, come down, and then back up again. And if it's negative, we flip that. The B is what's going to cause the vertical dilation. Horizontal dilation. So a stretch or shrink horizontal. And we get B by doing 2 pi over B. Or we get the period by doing 2 pi over B. So in a lot of these examples today, we're going to work backwards. We're going to need to find B. And we get B equals 2 pi divided by the period, which is basically what we get by just cross multiplying here with that 2 pi over B. But we're going to use this a lot today. And then the C is your phase shift or your horizontal shift. And remember that sine is opposite. So if it's a positive phase shift, then it actually goes to the left. If it's a negative phase shift, it goes to the right. And D itself is your vertical shift, which we're going to also identify. Obviously you can identify it by looking at your graph, but you can also find that by your midline. So a couple things, shortcuts kind of to remember amplitude. If I have a max and a min, then the max minus the minimum divided by 2 is my amplitude. And the max plus the minimum divided by 2 is my midline, which is also your vertical shift. So you can either do what we do here, find the amplitude, and then take that amplitude and subtract it from the max or add it to the min, or you can use this little formula, which is finding the average of the max and the min, and that's going to be your midline, and that's also going to be your vertical shift. Another thing that's going to be helpful is when we start to talk about our maximum and our minimums and when do these occur. So whether it's sine or cosine, your max points and your min points are always half a period away. The max to the max would be 1 full period, or the min to the min would be 1 full period. But the distance between the max and the min is equal to 1/2 the period. For sine, your max happens 1/4 of the way in, your minimum 3/4 the way in. For cosine, the max happens at 0, and the minimum happens 3/4 the way in, or 1/2 the way in, sorry. All right, so this first example says the function f oscillates between output values of -1 and 7. The table below gives the values of the function for the selected values of x. Without using technology, so no graphing calculator this time, write a sinusoidal function to model the data. Most likely, I would say, for most of us that are visual learners, it's going to be really beneficial to draw these out. And they don't have to be perfect, but if I know I'm at 0, -1, actually, let me make this a little bit smaller because I have to go all the way up to 7. So let's say this is -1. 0, -1 would be a coordinate point. And then we've got pi, 2 pi, 3 pi, 4 pi, 5 pi. And at pi, we're going to 3. So 1, 2, 3 here. At 2 pi, we're going to 7. So maybe 4, 5, 6, 7, all the way up here. Then back down to 3. Then back down to -1. And then back up to 3. So the graph of this function, let's start here. It goes up, it comes down, it goes back up again. So if I was to grab a model, and it could be sine or it could be cosine, because this one starts down and goes up and comes back down again, it might be easier to do a cosine, then I don't have to worry about a phase shift. So if I'm going to do a cosine there, then I all need my amplitude. Remember, it's the max minus the min. So 7 minus a -1, which becomes +1, divided by 2, and I get 8 over 2, and that's 4. So my A, or my amplitude, is 4. It starts down, it goes up, and then down again, which means this is a reflected cosine. Cosine normally starts up and goes down. So now I know that my A also has to be negative. There's no phase shift if we're starting here. If we're using cosine, if we wanted to use sine, we would have to do a phase shift. Next thing we want to find is B, and to do that, we need the period. So if I start here, I go up and I come back down again here, that's from 0 to 4 pi. So my period is 4 pi, and B is 2 pi over the period. So 2 pi over 4 pi is 1/2. Now I have B. We said there's no phase shift because there's no left or right movement. And then the last thing we would need to find is our vertical displacement. So my midline is definitely up here. So I can either look at that graph and find it, or I can take my max plus my min divided by 2, and I get 6 over 2, which is 3. So that y equals 3 is where my midline is, and 3 would be my vertical shift. So 3 is going to be D. And B was 1/2. So I get y equals, or f of x, actually in this case it's f of x. F of x equals the A, which was the -4 because it's upside down, amplitude of 4. We're doing cosine. B goes inside the parentheses, so 1/2 x, or theta. I'm using x just because they used x here, but you could also use theta. And then my vertical shift, which is up 3, so +3. And there's my sinusoidal function. All right, example 2 says a sinusoidal function is defined by, and this time we're doing sine. The function contains the input-output pairs of 8 pi 18 and 40 pi 18, which represent consecutive maximum values. So it's obviously important. What's the period for the function? What's the frequency? And what is the value of B? So if we wanted to do another little like visual on this, the first one is at 40 pi. Actually, the first one would be at 8 pi and 18. So I have a coordinate point here. And then the next one would be 40 pi and 18. And it's sine, which means that this came up, it came down, it went back up again. I don't know the amplitude, which is good because it's not asking for it, right? So I don't know how low this is going. I only know that these are maximum points. So this is going to give me my period from 40 pi to 8 pi is 32 pi. So that's our period, 32 pi. And then the frequency is 1 over that, so 1 over 32 pi. And then B in our equation, remember B equals 2 pi over the period. So 2 pi over 32 pi would be 1/16, and that's the value of B. All right, example 3 says a sinusoidal function is defined by g of x equals a cosine. So now we know we're using cosine. The function contains the input-output pairs of 0.42 and 6.18, which represent a max value and a minimum value. So instead of where the last one was both maximum values, this one has a max and a min. And it says respectively, which means in that order. So this first one is my max, and the second one is my minimum value. Then it says, what are the values of A and D? Find the equation of the midline, and what's the output value when the input is 12. So let's get a visual of what this function looks like first. So I have at 0.42 a maximum value. So here. And then at 6, so 1, 2, 3, 4, 5, 6, 18, I have a minimum value. So this is coming down, and then it's going to end up coming back up again. So I know a couple of things already. One is the distance between that max and the min would be half the period. So from 0 to 6 is actually half the period. That means that your full period is 12. I also know that my amplitude is the vertical distance or the vertical displacement between these two. So 42 minus 6 divided by 2, or 36 divided by 2, which is 18. That's your A. And if I want to find D, or my vertical shift, I'm going to do 42 plus 6 divided by 2. So 48 divided by 2, which is 24. And that's D. I also could have taken the 42 and subtracted the 18 to it, or the 6 and added the 18 to it. It also would have given you the 24, which leads you to the midline. The midline is y equals 24. So that midline would have been somewhere in here. And it says, what's the output value? And the input value is 12. Well, 12 is the end of that period, which means I'm back up again at the maximum value, which is 42. All right, example 4 says a sinusoidal function T of T models the average New Orleans temperatures in Fahrenheit as a function of time T in months after January 1st. According to the model, the highest average temperature of 92 degrees occurs about 3 weeks into July, and then they even estimate T for you there. So about 3 weeks into July would be 6 full months, and the third week into July, so like 0.7. The lowest average temperature of 57 degrees occurs about a half a year earlier. So a half a year earlier is going to be 6 months earlier, which means we're talking T equals 0.7 or 6.7 minus 6. So our high is 92. Our low is 57, but it happens beforehand, so it's going to come something like that. We want to find the equation for cosine. So I have my max and my min. If I want to find the amplitude, I'm going to do 92 minus 57 divided by 2. 35 divided by 2, which is 17.5. That's going to be your amplitude. The 92 plus 57 divided by 2 is going to give you the midline, which is your vertical shift. So this is 149 over 2, or 74.5. This is going to be D. This would be also the midline. Now the period, if you are starting the low at 57, and let's say this is 0.7, and then it peaks at 6.7, it's got to come down again for you to complete that period. So this is half a period here, which is 6. If T equals half the period, then the full period is going to be 12, because I just double it. So now I even know my period is 12. And if B equals the period, 2 pi over the period, then B is pi over 6. Now I have B. We're saying we start at 0.7, which means I also have a little bit of a phase shift here. Instead of it starting right at 0, it starts at 0.7. So this is a shift to the right, 0.7, which means I'm going to subtract 0.7 from theta in my equation. All right, so now let's put all that together. Your A, and if you look at the shape of this, it starts down, it's coming back up again. That means this is a negative cosine. So I have negative, my amplitude, 17.5. Cosine, the B, which we said was pi over 6, times T, which is my angle. With the phase shift to the right, 0.7, so minus 0.7, and a vertical shift up, 74.5. So that whole thing is my model. And actually, it should be T of T equals negative 17.5 cosine pi over 6 times T minus 0.7 plus 74.5. Now it says, according to the model, what's the average temperature on the last day of October? So you're looking for where T is 10. So I can actually take this, negative 17.5 cosine pi over 6 times 10 minus 0.7 plus 74.5. So my calculator must be in radians, because that's what these are, negative 17.5 cosine pi over 6, I'm actually putting it in my fraction, times 10 minus 0.7 with or without parentheses there, doesn't matter because it's going to do the multiplication first anyways, plus 74.5. So my calculator actually looks like this. And from here I get my value, or my degrees would be 77.571 degrees Fahrenheit. Okay, example 5 says the temperature in degrees Fahrenheit in Florence, South Carolina on a certain day at selected times T in the hours after midnight is shown in the table below. So our time is hours after midnight and the output is the Fahrenheit. Use the sinusoidal regression to find the model for the data. So we're going back to our calculators. We're going to input the data and we're going to get a sine regression. Okay, so I'm going to come in here. I'm going to enter my data 0, 3, 5, 9, 12, 16, 20, 24. And then I go to my Y values, 68, 64, 61, 65, 75, 78, 72, and 67. And we're going to go to our menu, our stat menu. We're going to go over to calc. And if you scroll all the way down, you're going to see sine reg. So that's letter C, but it is sine reg. And that's what we want to do here. Hit enter. Hit enter, enter, enter. I want to store it because I want something, part B asks for what happens when T is 14. So I go alpha trace, I get my Y1, and I calculate. And there's your sine regression. So Y equals, or actually in this case it's F of T, equals, my A is 7.9468, so 7.947, times sine. B is 0.2796, so 280. Theta, or T actually in this case. C is a minus, so minus 2.9375. I bump that one up. That also goes in the parentheses. And plus D, 69.935. So that whole thing is my regression model. Now B says use the regression model to predict the temperature at 2 p.m., which is 14 hours after midnight. So I'm going to go I'm going to go alpha. I'm going to get out of this screen. Alpha, Y equals, alpha trace, and get my Y1 again, and then 14. So at 2 p.m., my temperature is going to be 65.525 degrees Fahrenheit. It's important that you're comfortable using that sign. That is definitely going to be something that will be on the test portion that has the calculator. So you'll get asked to do the regression, and then you'll get asked for something based on that data, kind of like this question here. All right, last example. Example 6 says a weight attached to the end of a long spring is bouncing up and down. As it bounces, the distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reaches 3.3 seconds, the weight first reaches a high point 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. So if you could picture this string being pulled, so the object's being pulled down, and then it would bounce back up, and then it would come back down again, and it would bounce back up again. Now, in real life, eventually the bounce
lessens to where it would just go back to normal. But when we come up with these models, we assume that that pattern just continues on without end. So now let's think about what this looks like on an XY axis. So our spring at the beginning, obviously stopwatch would be at 0, is resting. And then it hits a max 0.3 seconds later. So at 0.3, it hits its max, which is 60 centimeters above the ground. Then it comes down and it hits a min 40 centimeters at 1.8 seconds. So that means it would come back up again. It would come back down again. That's where my curve is going to form. So already just with those two pieces of information, I know the max and the min gives me my vertical displacement. So I can find A and I can find the amplitude. So my max point would be at 0.3 comma 60. And it says point, so we're going to find one more in a moment. The minimum point would be 1.860. So, sorry, 40. And we have to figure out where that one duplicates again. So, because we know that this would be half the period, right? From max to min is half the period. I can find the period by doing 1.8 minus 0.3, and I get 1.5. So, that's half the distance, which means my full period would be 3 units. So that means that my max is going to happen again 3 minutes later. So 3.360 would be the next one. And my minimum is going to happen again 3 minutes later, or 3 seconds later. So it'd be 4.840. Now I have 2 sets of max and 2 sets of mins. Now I know my amplitude by doing 60 minus 40 divided by 2, so I get 20. Divided by 2, that's 10. That's my A. I know the midline would be 60 plus 40 divided by 2, which is 100 over 2, or 50, and that's my vertical shift. And my curve starts up here, comes down and goes up, so I know it's a positive cosine. The question is, I have to shift this over, which means my phase shift is shifted over 0.3 to the right, which means it's going to be minus 0.3. All right, so now let's put together what we have. We have a y equals my A, which was 10, cosine. My B, I have to find for my period. So if my period is 3, then B equals 2 pi over the period. So it's 2 pi over 3. My variable is time, so we can make it t or you can make it theta. You make it whatever you want, but let's make it t for time. Minus 0.3 for my phase shift, plus my vertical shift, which is 50. So 10 times cosine 2 pi over 3 times t minus 0.3, because I want to move it to the right, 0.3, plus 50, which was my vertical shift, or where my midline is. All right, take a deep breath before you start today's AP classroom and the initial homework. There are a lot of word problems. Do the best that you can, okay? All the information we've been getting on each of these just keeps coming back, so you just got to look for those important pieces of information. Make sure you submit your notes, and then use the remaining time to work on the 3.7 homework. Have a great day, guys.